Hi guys, welcome back to another video of me teaching, and today we're going to follow on from last video's Cauchy inequality, which is up on the board, by having 3 questions that I'll show you guys how to do. But before we get into all of that, I'm first going to explain kind of another version of this Cauchy inequality. Well, we see there are a bunch of squares, right? And just a note, in our questions, we actually don't have the squares. So how can we use this Cauchy inequality? Well, you can actually write the Cauchy inequality without squares. So you can actually write it as a1 plus all the way to an, and then times b1 all the way to bn. Surprised, right? But it's actually not at all surprising, because a1 that doesn't have a square, right? But it has a hidden square. Just take the square root of a1 and square it. Then it will be a1. So by using that and using the same logic for the Cauchy inequality, you can see that this is greater than or equal to the square root of a1 b1, and then plus all the way to the square root of an bn squared. Okay, so we're going to use this mostly for our 3 questions. And for the first question is a typical Cauchy question, like one of the easiest Cauchy questions to solve. So the question states that A, B, and C are positive, and we have to prove that A plus B plus C times 1 over A plus 1 over B plus 1 over C is greater than or equal to 9. So as we can see, the Cauchy formula and this, the Cauchy formula is the product of 2 sums. This is also a product of 2 sums. So we can use the Cauchy formula. So instead of 9, I write this is greater than or equal to square root of this times that, which is 1. So square root of 1 is 1. And same for the others, plus 1 squared is equal to 3 squared is equal to 9. So we have proved it. And for this question, we don't necessarily need to use the Cauchy inequality. We can also use AM, GM, HM formula. So we know that AM is greater than or equal to GM, which is greater than or equal to HM. But in this question, we don't have HM. So I'm just going to use AM greater than or equal to HM formula. So AM is A plus B plus C over 3, and HM is 3 over 1 over A plus 1 over B plus 1 over C. And if we just cross multiply, it will get what we want. So those are 2 methods. And then for the second one, it's just a little bit harder. You just need to use one little small technique. So question 2 still has the same criteria. So it is 9 over A plus B plus C is less than or equal to 2 times 1 over A plus B plus 1 over B plus C plus 1 over C plus A. So doesn't this look very similar as the one before? We were actually trying to make this into the one before. But how? Well, there is one small technique. I'm just going to multiply the A plus B plus C to the right-hand side. So I'm just going to write equals because I'm going to prove this later. Equals 2 times A plus B plus C times 1 over A plus B plus 1 over B plus C plus 1 over C plus A. Now, remember the last question. A multiplied by this cancels out and becomes 1. So that's what we want. So don't we want the thing that's multiplying here to be the sum of the denominators? And if you notice, the sum of the denominators is 2a plus 2b plus 2c. And if we distribute the 2, that's exactly what we want. So this will be equal to, instead I'm going to write this, of course, I think you can guess it as a plus b plus b plus c plus c plus a. And you can check 2b's, 2c's, 2a's. And we multiply it by 1 over a plus b plus 1 over b plus c plus 1 over c plus a. And then, of course, to make it more clear, so we see that this is greater than or equal to, I'll write it here, greater than or equal to, again, 1 plus 1 plus 1 squared, which is 9. And if we divide the a plus b plus c to the left-hand side, bravo. Okay, now up to the third question. The third question is a bit more spicier than this, but still very doable with the Cauchy inequality. So part of this still stays, it's just there's one more variable, d, which is in numbers, and a plus b plus c plus d is equal to 1. So here's the question, and I forgot the inequality. It's greater than or equal to 2. So this is what we have to prove. Well, how do we use the Cauchy inequality on this? Well, the Cauchy inequality needs two products of sums, right? Here we only have one sum. So don't we need just another bracket? And now I'll erase the 2 because this is what we're trying to prove. So, what do we need in this bracket though? Or what do we want? Well, if we notice on the previous two questions, I've said many times that what we want here is the sum of all the denominators. So I'll write that out. So it will be 4a plus 3b plus c plus all the way to 4b plus 3c plus d. And now, let's see. We see that this is greater than or equal to, of course, it'll be 1 plus 1 plus 1 plus 1 squared, since there are 4 fractions, which is equal to 4 squared, which is 16. But this is nowhere near to what we want. But actually, just one more little trick. If we add all of this up, you'll notice it becomes 8a plus 8b plus 8c plus 8d. So I'll just replace this. With 8a plus 8b plus 8c plus 8d. And if we factor out an 8, then the inside is just 1. So this bracket is actually just 8. So if we divide the 8 to the right-hand side, then 16 divided by 8 is 2. So this is indeed greater than or equal to 2. So we have proved this question. So these are the 3 questions that I wanted to show you guys about using the Cauchy inequality, or maybe a different version of the Cauchy inequality. Well, thank you guys so much for watching, and if you enjoy my videos, please consider liking and subscribing. If you want to master something, teach it.